Hello everyone. In this video, we are going to solve the problem number 1.64 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. We are having an inclined plane which is making an angle of alpha with the horizontal that is equal to 30 degree, and there is no friction between the pulley and this particular thread, and the mass m1 and m2 is connected using the thread and the pulley, and the coefficient of friction between mass m1 and this particular inclined plane is given as k is equal to 0.1, and for the mass ratio of m2 upon m1 is equal to 2 by 3. We have to find out the magnitude as well as the direction of the acceleration of the body m2. Now let us first find out the direction of this mass m2, then we will find out the magnitude. For that, let us go to the problem number 1.63, in which we have found out the expression or the condition on m2 upon m1, so that m2 is going either in the downward, upward, or is it at the rest condition. Okay, so first condition we have got, if m2 is going in the downward direction, then m2 by m1 should be greater than sin alpha plus k times cos alpha, where k is the coefficient of friction between mass m1 and this inclined plane. Let us say if mass m2 is going in the upward direction, then m2 by m1 should be less than sin alpha minus k cos alpha, and if it is at the rest condition, then this should be condition for m2 upon m1. So let us first find out the sin alpha plus k cos alpha, and let us see whether it is less than m2 upon m1. If this particular expression is less than m2 upon m1, then we can say m2 is going in the downward direction, and if this particular expression is greater than m2 upon m1, then we can say m2 is going in the upward direction. If both the condition is not satisfying, then we can say m2 will be at the rest condition, it cannot move. Okay, so let us first find out the value of sin alpha plus k cos alpha. Sin alpha, we can write it as sin 30 degree plus 0.1 times cos of 30 degree. So this is the value, that is equal to 0.59. And if we find the value of m2 upon m1, that is given as 2 by 3 in this particular problem. Now we can see here that 2 by 3 is nothing but 0.67. We can see here that m2 by m1 is greater than sin alpha plus mu cos alpha. That means we can say mass m2 is going in the downward direction. So this is one of the methodology through which we can find out the direction of mass m2. Let us say we are having second methodology in which we will first find out the value of m2g, that is the force acting in this direction m2g, that is the gravitational force. So m2 by m1 is given as 2 by 3. So we can write m2g is equal to, and from here we can write m2 is equal to 2 by 3 m1. So we can write 2 by 3 into m1 into g. If we draw the free body diagram of mass m1, then we are having in this particular direction we will have the force m1g sine of 30 degree. And if we find the value of m1g sine of 30 degree, that is equal to half into m1 into g. And we can clearly see that m2g is greater than m1g sine alpha or sine 30 degree. If this is the condition, even though we are not having any friction on this particular inclined plane, then also m2 will move in this particular direction. If there is the friction in this direction, then it can move in this particular direction a bit, but it cannot move in this particular direction. In that case, m1g sin alpha has to be greater than m2g plus that m1g cos mu m1g cos alpha, that is the friction force. But this is the case where m2g is more than 2 by 3 m1g, that is the force in the inclined plane. Okay, so let us find out the magnitude of the acceleration, as we have already decided the direction of m2 will be in this particular direction. So let us draw the free body diagram of mass m2. So we will have the gravitational force in this direction, that is m2g, tension force in this direction as the thread will pull the mass in the upward direction, and this is the direction of acceleration. So if we write the force equation in this direction, then we can write it as m2g minus t is equal to m2 into a. So this is the first expression we are having. And if we draw the free body diagram of mass m1, then this is the gravitational force m1g, and the normal reaction from the inclined plane, let us say n. And as mass m1 is moving in this particular direction, we will have the friction force opposite to the motion of mass m1, that is equal to k into n, where k is the coefficient of friction. And tensile will always act in this direction because it will try to pull the mass m1. Okay, and if we take the component of mass m1g as this is the inclined plane of angle alpha, then this particular component will be m1g cos alpha, and this particular component will be m1g sin alpha, because this angle will be 90 minus alpha and this angle will be alpha. So as there is no acceleration in the normal direction, then we can write it as n is equal to m1g cos alpha. And if we write the forces in the tangential direction, then that we can write it as t minus m1g sin alpha minus k times n, where n is m1g cos alpha. So we can write k times m1g cos alpha is equal to m1 into a. So this is our second expression. Now in order to find the value of a, we have to eliminate t from both the expression of 1 and 2. So let us add equation 1 and 2. So from here we will get m2g minus m1g sin alpha minus k times m1g cos alpha is equal to m1 plus m2 into a. So let us divide this particular expression by m1, as m2 by m1 is given. So we can write m2 by m1 into g minus g sin alpha minus k times g cos alpha is equal to 1 plus m2 by m1 into a. Okay, m2 by m1 is 2 by 3g minus sin 30 degree is half, so g by 2 minus 0.1 into root 3 by 2 into g equal to 1 plus 2 by 3 into a. So from here we can find a is equal to 2 by 3 minus half minus 0.1 into root 3 by 2 times g whole divided by 5 by 3. So let us evaluate this particular value. So we will get a is equal to 0.05 times of g. So this is the value of acceleration we got. The magnitude of acceleration is 0.05 g, and the direction of acceleration of mass m2 is in the downward direction, as we have evaluated this particular expression and we have found out that this particular expression is less than m2 upon m1, or we have stated that m2g, that is acting in this direction, is more than m1g sin alpha, and if it is, there is no friction, in that case also it can move in this direction. And if there is the friction, then also there is the tendency to move in this particular direction. It cannot move in this direction. Okay, I hope the entire procedure is clear. Thank you.